Hi, and welcome to this introduction to Simulink, which will get you started with the basics. Before I begin, I should mention that this video was recorded using MATLAB version 2020A on Windows, which I guess most of you will be using. But even if you don't, that's probably fine, because the differences between the newer versions aren't all that significant. And then as for those of you who are taking the nonlinear control course at Lund University, there will be an accompanying PDF, which more or less mirrors what I'm about to go through here. But in addition, it contains some interesting examples for you, so I would suggest checking that out. Yeah, so alright, let's get started. The way to open up Simulink is by either pressing this block here, or typing in Simulink in the command window. And once we get here, we just create model in the blank model box to get started from scratch. Now the way Simulink works is by bringing together a set of blocks and then connecting them. And the easiest way to illustrate this would probably be to simulate a step response of an easy-looking transfer function. So in order to do that, we need blocks, which correspond to the input, the transfer function, and an output. And we find our blocks in the library browser, which is super important. So let's begin with input, which we usually find in the sources category. Scroll down a bit. It's in alphabetical order, so that helps. And then find our step block. Now all you do is just drag it out and place it somewhere convenient. Moving on to the continuous category, we find our transfer function block a bit further down. And just drag it out. And finally, in the sinks, we tend to find our output blocks. And in this case, we want the scope to be able to plot our output. And now that we have our blocks, all we do is connect them with the arrows. Alright, so before we actually perform our simulation, we might want to choose a proper stop time. And the way to do that is by right-clicking anywhere more or less, and then choosing Model Configuration Parameters, or just Control-E. And here, as you can see, we have stop time, which we can change to 5, just because. Right, and now, in order to run the simulation, all you do is click here, or press Control-T. And that's it. And in order to see the output, just double-click the scope block. And we see that we have a typical first-order step response behavior. And that's because the default transfer function is 1 divided by s plus 1. But we could easily change that by by double-clicking on the block. As you can see here, the row vectors here determine the transfer function. And the way that works is that the element in the vectors correspond to some coefficient in the denominator and numerator polynomials in the transfer function. So for instance, if I change this to 0.5 and 2, that would correspond to a denominator polynomial s to the power of 2 plus 0.5s plus 2. So it just takes out the coefficients, more or less, and gathers them in a data vector. All right, and if we try to simulate this, then we see that we get a more typical second-order behavior. All right, let's say we want to look at another type of input. Then we just press the step block and press delete, so it disappears, and then go to sources. Let's say we want a sine behavior. We can just drag a single generator out, which actually gives us a couple of different choices. As you can see here, we have some choices here, but let's go with sine, and let's just pick amplitude 1 and frequency 1. So if I run the simulation, yeah, you can see that I should probably choose a longer stop time, so the initial transient disappears. But another option for us is to, in order to watch the simulation real time, we could go here below run and click simulation pacing, and then check this box. And then to give us some time to actually watch it, we could just go and change the stop time to something really, really big. All right, now we're ready to click run. Now, as you can see, the pacing is active and the clock is ticking. So if I just double click here, you can see that now we can't see much because the stop time was chosen such a big number, but you see that there is some yellow there. So if we just click here, or to zoom in and choose an area like this, maybe even a bit more, you can see that, yes, we get a shiny behavior in real time. And we can actually change the parameters mid-run as well. So, for instance, if I want to input a sine wave with a smaller amplitude, that's completely fine too. We'll get some transient, but after that it should settle. And then we could also change the transfer function to do something like this maybe. And then again, we get some transient initial different behavior. So yeah, and when you eventually get bored of watching this, you could always click stop here, stop button, to stop your simulation. All right, so now that you know how to perform easy simulations, you might also be interested in analyzing your data, preferably in MATLAB. So the thing is that Simulink and MATLAB actually communicate, and they do it both ways. So for instance, if I create a new variable called num, like this, then I could go into the transfer function block and actually choose this variable to determine a new transfer function. And for the other way around, maybe I'd be interested in having my inputs and output data exported to MATLAB for analysis. And I can do that. That's a kind of output, right, to MATLAB. So therefore we go into the simulation block, we'll look under the output category, sinks, choose to workspace, which will drag out close to our input and output. And the way to connect them is simply by pressing the arrow and then like that. All right, now before we export it, before we run our simulation, we might also want to change the name because Simulink is visual, but MATLAB isn't as visual, so we want to distinguish the two data vectors. So we choose U here for the input, then array to get a data vector, and the same thing here. We can just remove the pacing as well. All right, so if we just run it, we see that in MATLAB now, there is a new variable called out. And if we just type it out to see what it contains, see that there are three vectors there, y, u, and t-out. And t-out will then be will then contain our time points. And the way to retrieve these vectors is simply by typing out, followed by a dot, followed by u, for instance. And we see that we get our data vector, which we can then analyze. So that's it for this introduction. Hopefully by now you feel that you can perform easy simulations and then export your data to MATLAB for further analysis. Thank you for watching.